Om Ishar Research and Education presents lecture number 9 on product development. Two topics to be covered in this lecture are concurrent engineering and QFT, and this is part of the lecture series on operations management. Your teacher today is Dr. Subhash Kakkar. He is PhD from Faculty of Management Studies, Delhi University, Delhi, India. He is MBA from Faculty of Management Studies, Delhi University, Delhi, India. He is also BE Mechanical from Delhi College of Engineering, Delhi University. He is Six Sigma Master Black Belt and also SAP R3PP consultant. He is having over 40 years experience of corporate sector and academics. Presently, he is working as director in Omishal Research and Education Center, Delhi, India. Today's topics are concurrent engineering and quality function. Concurrent engineering is a strategy where all the tasks involved in product development are done in parallel. All the activities are done simultaneously. Collaboration between all individuals, groups and departments within a company. Customer research, designers, marketing, accounting, engineering, they work all together and simultaneously. And the process of designing starts with the idea generation. People involved in idea generation are competitors. We get the information from competitors, suppliers, research and development department, customers, and the marketing department. And idea is generated. Product or service concept is received from the idea generation. A feasibility study is made and then performance specifications are ready with us. A preliminary design is formed and form design, functional design and production design. These three departments work together and the ideas from one department to the other are transferred. And revising and testing of the prototypes are done. Functional design gives the design specifications. Form design revise and test the prototypes. Production design gives us the manufacturing specifications. And then pilot, run and final tests are made on the prototype. Final design and process plans are made and finally the product is launched in the market. And this is a linear. Again we repeat, idea generation through competitors, suppliers, research and development, customers and marketing department, product or service concept is received. All the information coming simultaneously. Techniques used are perceptual mapping, benchmarking, and reverse engineering. Conceptual or perceptual mapping compares customers' perception of available products. In the 4 quadrants, the available products are placed and decisions are made on our own product and in which quadrant it is going to lie. Identify gap in market and benchmarking is also carried out to get the best product available, base performance specification for new product on it. Reverse engineering, dismantle and inspect competitors' products to know the features, the way these are made, what sort of design they have taken into account, and then select finally the features to incorporate in. Next is feasibility study. Performance specifications are made, demand for the proposed product, how much it is ascertained. Cost of developing and producing the product is also calculated. Does company have manufacturing capability to manufacture the product as per the design we have already thought of? Skilled personnel, are they available in the company? And then is the preliminary design. Form design, revising and testing, prototypes, functional design, design specifications are prepared. Under production design, manufacturing specifications are made. All are working together to give us the preliminary design. Form design is nothing but physical appearance of the product. Functional design, performance of the product. Production design, how to manufacture. And finally, pilot run and final tests are carried out. Final design and process plans are finalized. Prototype produced, adjustments made, if any required. Final specification are agreed upon. And then finally, product is launched. Manufacturing process commences. Product is marketed to buying public. And this shows that how the two processes of launching a product are there. One is traditional process, which is called linear process, versus concurrent engineering, which is team collaboration. On the top, the traditional process is shown. Consumers give us the idea of the product, and the product concept is then transferred to the marketing personnel, and from marketing personnel, performance specifications are prepared and given to design and manufacturing engineering, and then manufacturing specifications are prepared and these are given to production personnel. This is the process which is carried out one after the other in sequence. But look at the diagram where the concurrent engineering concept is given, which is a team concept. All the heads sit together, like marketing personnel and design department and then production department. They sit together and decide on the product design and the way it is to be manufactured. And this is called concurrent engineering, when all the activities take place simultaneously. Why concurrent engineering is preferred? Pace of market change has increased. Companies must keep pace with changing markets. Decisions made sooner rather than later. No delay is there in taking the decision. And it reduces and eliminates repetition of tasks. And it also reduces waste and reworking of design. Product quicker to the market. Maximizes company profit. Company operates more efficiently if it uses concurrent engineering. To make decisions concurrently, team knows the design goals and the objectives. Team is aware of the interrelationships between all aspects of the design process. Superior communication between all sections of the company exists. And method finally is used, quality function deployment. Quality function deployment, collection of matrices. Those convert the needs of the customer into technical specifications at all stages of the design and manufacture process. Product planning, most popular concept is house of quality, which is nothing but quality. This concept was used by Dr. Mizuno, Professor Emeritus of the Tokyo Institute of Technology, is credited with initiating the quality function deployment system. The first application of QFD was at Mitsubishi Heavy Industries Limited in the Kobe shipyard, Japan in 1972. After 4 years of case study development, refinement and training, QFD was successfully implemented in the production of minivans by Toyota. Using 1977 as a base, a 20% reduction in startup costs was reported in the launch of the new van in October 1979. A 38% reduction by November 1982 and a cumulative 61% reduction by April 1984. Looking at the house of quality in the quality function deployment, it is house of quality and all these walls at the roofs show some metrics or the other. Number one is customer requirements, prioritized on a scale or as percentage. Number two is competitive product evaluation. Number three is engineering characteristics. Fourth is interrelationships of 1 and 3. Means customer requirements and engineering characteristics. Number 5 is, which is the roof, relationship between engineering characteristics. And 6 is targets for new product. So this is house of quality. All these matrices are used in this. First application of QFD was at Mitsubishi Heavy Industries Limited in Kobe shipyard, Japan in 1972, which we have already discussed. And QFD was introduced in 1984 by Dr. Clausing of Xerox. Quality function deployment is a planning tool used to fulfill customer expectations. Quality function deployment focuses on customer expectations or requirements, often referred to as the voice of customer, and these are matched with the voice of process. It is employed to translate customer expectations in terms of specific requirements into directions and actions in terms of engineering characteristics that can be deployed through product planning, part development, process planning, production planning, and service. Quality function deployment was originally implemented to reduce startup costs. Organizations using QFD have reported a reduced product development time. For example, US car manufacturers of the late 1980s and early 1990s needed an average of 5 years to put a product on the market, from drawing board to showroom, whereas Honda put a new product on the market in 2.5 years and Toyota did it in 3 years. Both organizations credit this reduced time to the use of QFD. Product quality and consequently customer satisfaction improves with QFD.